simplify the integral of, so we got a polynomial divided by another polynomial, so a rational function. So we're trying to integrate a rational function here, which to me, immediately what springs to mind is, oh, I should do partial fraction decomposition. Unless I see something very specific, maybe then a substitution might be in order. But no, partial fractions decomposition, probably the best thing to do here. Okay. Do a quick little check. We've got a degree 2 polynomial times a degree 1 polynomial. Somebody factored the bottom, probably to make my life a little easier. So the bottom has a degree of 3, which is strictly greater than the 2. It's a quadratic up on top. Okay. So this is a proper rational expression. We don't need to do polynomial long division to rewrite it or anything like that. But we should be in the habit of checking that just in case we have to do a polynomial long division. Okay. Now, the bottom appears to be factored. Looks like we have a linear term and an irreducible quadratic, but you always want to make sure nobody's trying to trick you. No one's trying to pull a fast one on you. A quadratic, x squared plus bx plus c, is irreducible if b squared minus 4ac is less than 0. Well, what do we got here? We got an a of 4, we've got no b, and we've got a c of 1. So that's 0 squared minus 4 times 1, negative 16. You betcha, 4x squared plus 1 is irreducible. So we do have an irreducible quadratic and a linear term. We only have one of each. So the setup for the partial fraction decomposition is going to be fairly straightforward, I would say. Okay. So we get minus 20x squared, 4x squared plus 1 down here, and I think it was x minus 3. But I do not remember off the top of my head what the top was. 2x and minus 11. Okay. So what do we do? What's our setup? So we'll start with the quadratic. So we get to ax plus b over 4x squared plus 1. Right? You always put a generic linear term above each quadratic when you're doing your partial fraction decomposition. That's what we've learned. And then we need just a single constant over the x minus 3 part. So our new goal, right? Well, ultimately we're trying to integrate, but our new goal right now is let's figure out what a, b, and c are. Okay? What I like to do, I like to multiply both sides by the denominator here. So we'll multiply by 4x squared plus 1 times x minus 3. We multiply both sides by it. And what that does is effectively it raises everything up to just be a bunch of polynomials. Everything cancels on this side. We're just left with the numerator over here on the left. And on the right, the 4x squared plus 1 will cancel out with this, and you'll be left with ax plus b times x minus 3. And then, when you multiply the c over x minus 3 by the denominator, the x minus 3's now cancel, and you're left with c times 4x squared plus 1. Okay. Now, if we were just dealing with sort of distinct linear factors, you would very easily be able to choose some values of x to plug in here to make your life a lot easier. Okay. What I find with irreducible quadratic, because I can't choose any x to make this 4x squared plus 1 equal to 0, that's kind of what makes it an irreducible quadratic, I find the best thing for me is to expand out the polynomial on both sides. So we get ax squared minus 3ax plus bx minus 3b plus 4cx squared plus c. Okay. Now, two polynomials are equal exactly when their coefficients are equal, so let's group things together. So minus 20x squared plus 2x minus 11 is equal to, there's going to be a little bit of back and forth here. Okay, look for x squareds. So x squared, x squared. So a plus 4c's. That's the coefficient of x squared. All right, let's look for x's. Minus 3ax's plus bx's, and that's it. So we'll say b minus 3a x is there. Okay. And then we'll use green for the last one. So our constants, c minus 3b. C minus 3b. And there we go. All right. So what does that mean? Well, as I said, polynomials are only equal. Two polynomials are equal exactly when their coefficients are equal. So that means c minus 3b has to be equal to this constant term, negative 11. 2, the coefficient of the x's, has to be the same as b minus 3a. And then a plus 4c has to be the same as the coefficient over here for the x squareds, which is minus 20. Okay, great. Where can we go from here? Well, let's see. We could try and rearrange. If we rearrange the last equation, we'll get c is 3b minus 11. Okay. And if we rearrange the second equation, we can easily solve for b. b is 2 plus 3a. We can combine those two together, right? Take this b, put it in here, and we can see that c is going to be 3 times 2 plus 3a minus 11, which will be 6 plus 9a minus 11. So c is going to be 9a minus 5. So if I figure out what a is, I will know what c is. If I figure out what a is, I will know what b is. There's one equation we haven't used yet. If you want to stay organized when you do something like this, you can label your equations 1, 2, and 3. Okay? But we can take this expression for c, take it all the way and put it in here. You'll get a plus 4c, so that's 9a minus 5, is negative 20. So you'll get 1a, 36a's, that's 37 a's. 4 times minus 5 is negative 20. If we add 20 to both sides, we see that 37a is 0. So what does that mean for us? That means a is going to be 0. But if we plug that in here, that means c is going to be negative 5. And if we plug in a as 0 here, we get b is 2. So we have all our constants as needed. We're done with the partial fraction decomposition part of it all. We're now in a position to integrate. So let's bring back the integral symbol, and we will also summarize what we just achieved. Was it plus 11? No, it was minus 11. Silly me. There we go. We had 4x squared plus 1 times x minus 3. Okay. And so this whole expression in here is the same as ax, so 0x, plus our b, which was 2, over 4x squared plus 1, plus our c, which is negative 5, or I guess you could write minus 5 over the x minus 3, the linear term. Right? That's what it was. That was what our setup was. ax plus b over 4x squared plus 1, c over x minus 3. So there we go. You can clean it up a little bit by getting rid of that 0x. We don't need that there. So really it's 2. Okay? But what we found is this complicated looking rational is the same as the difference between these two rationals. And these are much easier to integrate. If we separate them, we can split up like this. Okay. And then we can use the building blocks that we know to very quickly integrate them if we have them memorized. Right? So we get minus 5 ln absolute value of x minus 3. And then over here, what are we going to have? We're going to have 2 times, we'll give it a little bit of space. The quadratic ones are always a little bit bigger. But we have the 2 out here times, what is it? You'll have 2 over the square root of 4ac minus b squared times arctan of 2a, so that's 4x plus b, well there's no b's, so that's 0 still, and then over the square root of 4ac minus b squared. Okay. And then if we clean that up, you're going to get what? So that's going to be square root of 16 here. So that's going to be 4. 2 times 2 divided by 4. That's going to be nothing. We'll have 8x's here over square root of 16. So 8 over 4, 2. So we'll be left with arctan of 2x minus 5 ln x minus 3. It was an indefinite integral, so let's not forget our plus c here at the end. And so there, using our building blocks very quickly, we have our answer.